everyone. Today we will discuss about laws of exponent. But before we proceed to the discussion, so let us have some recall of the basic knowledge about the exponent. Okay? So we have here 8 squared. So it means that 8 will be our base and 2 here will be the exponent. And 8 squared means it is equal to 8 times 8. So the exponent means that you will multiply the given number, the base, 2 times to itself. And what is 8 times 8? So it is equal to 64. So it means that if we have 8 squared, it is equal to 64. Now let's have some additional examples. So let's say we have here 2 cubed. So 2 will be our base and 3 will be our exponent. And this is read as 2 cubed. And 2 cubed is equal to 2 times 2 times 2. So the exponent tells how many times we're going to multiply the base to itself. And we have here 3 as an exponent. So it means that we will multiply 2 to itself thrice, 3 times. So 2 times 2 times 2. And 2 cubed is equal to 2 times 2, which is 4, times 2, which is 8. So therefore, 2 cubed is equal to 8. Now, let us have 3 raised to 4. So here, we have the base 3 and we have the exponent, which is 4. So it means that we were going to multiply 3 to itself 4 times. So we have here 3 times 3 times 3 times 3. So what is 3 times 3? 9. Times 3, 27. Times 3, 81. So therefore, we have here 3 raised to 4 is equal to 81. So this is the basic concept about exponent. But before we proceed to the laws of exponent, do not forget to share this video, subscribe to our channel, and hit the notification bell. Now, let us discuss the laws of exponent. So, for number 1, we have here product law of exponent. So, what do we mean by this product law of exponent? We have here m raised to x times m raised to y. It is equal to m raised to x plus y. But take note that we will only add the exponent if and only if we have the same base. So for example, we have here x raised to 5 times x raised to 3. So take note that we have the same base, so we can follow the product law of exponent, that if we have the same base, we can add their corresponding exponent. So we have here x raised to 5 times x raised to 3. So we have here x raised to 5 plus 3. So if we're going to simplify it, it will become x raised to 8. So therefore, if we have here x raised to 5 times x raised to 3, it is equal to x raised to 8. Okay, so let us have another example. Let's say we have here a squared b times a cubed b squared. So how are we going to apply the product law of exponents? So take note that we can only add the exponent if we have the same base. So we can add the exponent of a because we have here the same base a and also with the same base b. So we will have a raised to 2 plus 3. So we have here a raised to 2 plus 3 times b raised to 1 plus 2. So take note that if we don't have an exponent here, it means that the exponent is 1. So we will have b raised to 1 plus 2 and then simplify. So we have here a raised to 2 plus 3. So we have here a raised to 5 times b raised to 1 plus 2. So we have here b raised to 3. So if we're going to simplify this using the product law of exponent, we have here a squared b times a cubed b squared. So it is equal to a raised to 5b cubed. Okay? So now, let us proceed to the second law. So we have here quotient law of exponent. And we have three cases here for the quotient law of exponent. So let us have number one case for quotient law. So we have here m raised to x over m raised to 1. So it is equal to m raised to x minus y. So take note that if it is product law, we add their corresponding exponent if and only if they have the same base. Now, for the quotient law, it is also the same that we can only subtract the exponent if it is division with same base. Okay, again, we have here m raised to x over m raised to y, which is equal to m raised to x minus 1. If x is greater than y, so that's the first case. So we will follow this if x is greater than y. So let us have example. Let's say we have here y raised to 5 over y squared. So we have here the same base, which is y. Then we have here the exponent, which is 5. And then for the denominator or the divisor, we have 2 as an exponent. So therefore, we have here x is greater than y. So we have 5 is greater than 2. So if the exponent of the numerator is greater than the exponent of the denominator, so we will have here m raised to x minus y, wherein our m is 1. So we have here y raised to 5 minus 2. So what is 5 minus 2? We have 3 as the exponent. So therefore, if we have y raised to 5 over y raised to 2, it is equal to y raised to 3. So let us have some more example for this particular case. So let's say we have here m raised to 7 and raised to 3 over m squared n. So we have here an example. So we can only subtract the exponent with the same base. So we will have here m raised to 7 minus 2, then n raised to 3 minus 1. So we will have the answer, which is equal to m raised to 5 n squared. So m raised to 7 n cubed over m squared n is equal to m raised to 5 n squared. So we will only subtract the exponent to its corresponding term with the same base or same variable. Okay? So in this case, wherein the exponent of the numerator is greater than the exponent of the denominator. Now for the second case here, we have here m raised to x over m raised to y. It is equal to m raised to x minus y equals 1 if and only if x is equal to y. So for example, we have here a raised to 5 over a raised to 5. So if you notice, we have the same exponent of the variable or the base in the numerator and also with the denominator. So therefore, it is equal to 1. If x is equal to y, so we have here 5, and we also have here 5 as an exponent. So it means that if we have a raised to 5 over a raised to 5, so it is equal to 1. Okay? So for example, another one. We have here x squared y cubed over x squared y cubed. So if we have here the same base, which is x, then the same exponent, which is 2. Then again, we have here the same base, which is y. Then we have the same exponent, which is 3. So it is equal to 1. So that's the second case. If the exponent of the first or the numerator is equal to the exponent of the denominator with, take note, with the same base. Okay? Now for the third case, for the quotient law of exponent, we have here m raised to x over m raised to y. It is equal to 1 over m raised to y minus x if x is less than 1. Okay? So I hope you understand this, and you will understand this quotient law if we're going to give examples. So let's say we have here y raised to 2 over y raised to 5. So if you notice, again, this is true only if we have the same base. So we have the same base here, which is y. So we have here the exponent of y in the numerator is less than the exponent of y in the denominator. So we have here x is less than 1. So if x is less than y, we will have this answer, 1 over m raised to y minus x. So we will have here 1 over y raised to 5 minus 2. So our y minus x, so y is the exponent of the variable in the denominator. So that's why we have here 1 over y raised to 5 minus 2. Okay? And if we simplify it, it will be equal to 1 over y cubed. So the answer for y squared over y raised to 5 is equal to 1 over y cubed. Okay? So now let's have another case. So we have here, let's say we have a to the 4th b squared over a to the 6th b cubed. So we have here example. So if you notice, we have the same base, which is a. Then the exponent of a in the numerator is smaller than the exponent of a in the denominator. And we also have the same base, which is b. And the exponent of b in the numerator is less than the exponent of b in the denominator. So it will become 1 over a raised to 6 minus 4 times b raised to 3 minus 2. So what will be our answer? So we have here 1 over a raised to 6 minus 4, which is 2, and b raised to 3 minus 2, which is 1. So no need to write 1 if 1 is the exponent. So therefore, the answer for a to the 4th b squared over a raised to 6 b cubed is equal to 1 over a squared b. So I hope you understand the first two laws of exponent. If you have question, just comment it below this. Let's proceed to our third laws of exponent. So we have here power of a power rule. So we have here m raised to x raised to y. So we have here a certain base, which is m raised to x. Then we have y as an exponent. So we read it as m raised to x quantity raised to y. So it is equal to m raised to x times y. So if we have a particular base here with an exponent, then another exponent outside the parentheses, it means that we will copy the base, then multiply the exponent. So we have here xy. That's why we have here xy means x times 1. So let us have example for more detailed explanation of the third law. So we have here the quantity of a raised to 5 raised to 2. So we have here the base a raised to 5, then we have a particular exponent outside the parentheses. So it means that we copy the base, then multiply the exponent. So we have here 5 times 2. And what is 5 times 2? So we have here 10. So we have a raised to 10. So if we have here a, the quantity of a raised to 5 squared, it is equal to a raised to 5 times 2. Simplifying it, so we will arrive with a raised to 10. Okay? So let us have more example. Say we have here b raised to 3, quantity raised to 4. So we have here equal to b raised to 3 times 4. And what is b raised to 3 times 4? So we have here b raised to 12. So that is the power of a power rule. So I hope you understand this third laws of exponent. Now let us proceed with the fourth one. So we have here power of a product. So if we have here mn, so we have two variables here, then quantity raised to x, it means it is equal to m raised to x and raised to x. Okay? So we will distribute the exponent outside the parentheses to each of the variables given inside the parentheses. So to understand it more, so let us have an example. So say we have here the quantity of m squared n cubed raised to 4. So it's a combination of the power of a product and the power of a power rule. So we will distribute the exponent outside the parentheses by multiplying it to the exponent of each variable inside the parentheses. So it means that we will have m raised to 2 times 4, then n raised to 3 times 4. So we will distribute the exponent by multiplying it to the exponent of the variable inside the parentheses. So simplifying it, we will arrive with m raised to 8. So 2 times 4 is 8. And raised to 3 times 4, which is 12. So the simplified form of the quantity of m squared n cubed raised to 4 is equal to m raised to 8 n raised to 12. Now let us have more example of the power of a product. Let's say we have here 2x y squared raised to 3. So it means that, again, we will distribute the exponent outside the parentheses to each of the exponent inside the parentheses. So we have here 2. And 2 means that it has an exponent of 1. So it will be 2 raised to 1 times 3. So times 3. Then we have here x raised to 1 times 3. Then we have y raised to 2 times 3. So we will distribute the exponent of 3 outside the parentheses to each of the exponent of the constant or the variables inside the parentheses. So let us multiply. So we have here 2 raised to 1 times 3, which is 2 cubed. X raised to 1 times 3, so which is 3. So we have here x cubed. And then y raised to 2 times 3, which is 6. But we can simplify the numerical coefficient here. So we have here 2 cubed. So what is the simplified form of 2 cubed? So again, we recall this in our first part of this video. So what is the simplified form of 2 cubed? So it means that it is 2 times 2 times 2. So it tells the exponent tells you how many times you're going to multiply the base to itself. So what is 2 times 2 times 2? So we have 8. So we have 8x cubed y raised to 6. So the simplified form of the quantity of 2x y squared raised to 3 is equal to 8x cubed y raised to 6. By applying the power of a product and, joining with the power of a power rule. Now, let us have the last law of exponent. So, we have here power of a quotient. So, it is just like the same with number 3. So, and number 4, power of a product. But this time, this is for the quotient or fraction. So, we have here the quantity of m over n raised to x. So, it will become m raised to x over n raised to x. So it means that we will distribute the exponent outside the parentheses by multiplying it to each of the exponent of the variable or number inside the parentheses. So let us have example. Let's say we have here x over y, the quantity of x over y raised to 5. So it will be equal to, so it means that there is an exponent of 1 here and also 1 here. So it will be equal to x raised to 5 over y raised to 5. Following this rule that if we have m over n, quantity raised to x, so it will become m raised to x over n raised to x. So we have here x over y, the quantity of x over y raised to 5. So it will become x raised to 5 over y raised to 5. So we can have it power of a quotient combination of a power rule. So let us have example. Let's say we have here 2a squared over b cubed quantity raised to 4. So we have here distribute 4 to each of the exponent given inside the parentheses, even if it is a number or a variable, in the numerator and also with the denominator. So it will become 2 raised to 1 times 4 times a raised to 2 times 4 over b raised to 3 times 4. So we distribute 4 by multiplying it to each of the exponent in the number and variables inside the parentheses. So let us simplify this. So we have here 2 raised to 1 times 4. So we will have 2 raised to 4. Then a raised to 2 times 4, which is 8. Over b raised to 3 times 4, which is 12. But we need to simplify 2 raised to 4. So we have to simplify it. We have the exponent 4. It means that we will multiply 2 to itself 4 times. So we have here 2 times 2, which is equal to 4, times 2, which is equal to 8, times 2, which is equal to 16. So 2 raised to 4 is equal to 16. Then we have here a raised to 8 over b raised to 12. So I hope you understand the laws of exponents. So if you have question, just type your question in the comment section. Okay, let us have more examples for the laws of exponents. So simplify. Number 1, we have here the quantity of negative x raised to 6 raised to 5. So this is the combination of the power of a power rule and the what we call the power of a product. So we have here, so again, if we have negative x raised to 6, it means that the numerical coefficient is negative 1. Okay? So it means that if we have negative 1 as the numerical coefficient and it has an exponent of 1, then multiplied by 5. Then x raised to 6 times 5. So let us simplify. We have here negative 1 raised to 1 times 5, which is 5. Then x raised to 6 times 5, which is 30. Then let us simplify the numerical coefficient. So it means that we will multiply negative 1 5 times to itself. So negative 1 times negative 1 times negative 1 times negative 1 times negative 1. So we have here negative 1 times negative 1, which is positive 1. Then positive 1 times negative 1 is negative 1. And negative 1 times negative 1 is positive 1. And positive 1 times negative 1 is negative 1. So therefore, the simplified form of negative 1 raised to 5 is negative 1. And then we have here x raised to 30. But of course, negative 1 x raised to 30 is the same with negative x raised to 30. So no need to write 1. So it means that the numerical coefficient is negative 1. So the final answer will be negative x raised to 30. Okay, I'll just give you a quick explanation for the getting the simplified answer for the sign. We have here the base, which is negative, and the exponent. So take note that if the base is negative and the exponent is an odd number, the product results to a negative number. But if it is an even number, the product results to a positive product. Okay? So it's just a quick method on how to get the sign of the product if we're going to simplify a particular number with a negative sign with the corresponding odd or even exponent. Okay? So we have here example number 2. So here, we will use the power of a power and then the power of a quotient. But before we use that, so let us see to it that if we can already simplify the numerical coefficient. So we have here 8 over 4. So we can simplify it. What is 8 over 4? So it is equal to 2. So we have here 2m cubed over n to the 4th quantity raised to 2. So we just simplify 8 over 4. Now let us distribute 2 to each of the number and variables inside the parentheses. So we will have here 2 raised to 1 times 2, m raised to 3 times 2, over n raised to 4 times 2. And then let us simplify. So what is 2 raised to 1 times 2? So we have 2 raised to 2. Then m raised to 3 times 2, we have 6. Over n raised to 4 times 2, we have 8. Now, let us simplify more the numerical coefficient. So, what is the value of 2 raised to 2? So, it means that it is equal to 2 times 2, which is 4. So, we have here 4m raised to 6 over n raised to 8. Take note that we cannot subtract the exponent of m and n. We cannot subtract 8 by 6 or 6 by 8 because we have different base here. One is m and the other one is n. So this will be now our final answer. So the simplified form of 8m cubed over 4n to the 4th raised to 2 is equal to 4m raised to 6 over n raised to 8. Now let us discuss example number 3. We have here the quantity of 2x cubed y squared z raised to 5. So again, this is a combination of power of a power and the power of a product rule. So let us distribute simply multiplying 5 to each of the exponent of the constant and the variables of the literal coefficient inside the parentheses. Okay? So we will have 2 raised to 1 times 5. Then we have x raised to 3 times 5. Then we have here y raised to 2 times 5. And z raised to 1 times 5. C raised to 1 times 5. Then let us simplify. So what is 2 raised to 1 times 5? So we will have 2 raised to 5. Then x raised to 3 times 5, which is 15. Then y raised to 2 times 5, which is 10. And z raised to 1 times 5, which is 5. Now let us simplify the numerical coefficient. So we have here 2 raised to 5. And what is the value of 2 raised to 5? So it means that we will multiply 2 to itself 5 times. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. And 16 times 2, 32. So therefore, the numerical coefficient is equal to 32. Then we have x raised to 15, y raised to 10, z raised to 5. So this will be the simplified form of the quantity of 2x cubed y squared z raised to 5. Now let's proceed to example number 4. So we have here the quantity of 6a to the 4th b squared c times the quantity of 2ab squared c cubed. So we will use the rule here. So we will use the product law of exponent. And we will multiply the corresponding numerical coefficient. And take note that we can only add the exponent if and only if we have the same base. So we will add the exponent of a, we will add the exponent of b, and then we will add the exponent of c. Okay? So we call it as the product law of exponent. Okay, so what is 6 times 2? So we have here 12. So again, 12 came from 6 times 2. So multiplying the numerical coefficient. Then we have here a to the 4th times a. So it will be a raised to 4 plus 1. Then b squared times b squared. So we will have b raised to 2 plus 2. Then we have here c times c cubed. So we have c raised to 1 plus 3. Okay? Then let us simplify. So we have here 12a raised to 4 plus 1, we have 5. b raised to 2 plus 2, we have 4. And c, we have here 1 plus 3, 4. So therefore, the simplified form of the quantity of 6a to the 4th b squared c times the quantity of 2ab squared c cubed is equal to 12a raised to 5, b raised to 4, c raised to 4. Take note ha, huwag kayong malilito kung kailan ba minumultiply yung exponent at kung kailan ina-add. So we will multiply the exponent if we have the exponent outside the parentheses to each of the exponent of the variables and the numerical coefficient inside the parentheses. But for this particular example number 4, it means that we are multiplying a monomial by another monomial and there's no exponent outside the parentheses. It means that we will just simply add the exponent of the same base. So that's why we add the exponent of a, exponent of b, and exponent of c. Now let us have the example number 5. So we are given here the quantity of 2m cubed n to the 5th over x squared y cubed raised to 2 times the quantity of x squared y z cubed over 3mn squared raised to 3. Okay, so take note that we have the exponent outside the parentheses. So it means that we will multiply this exponent to each of the exponent of the constant and the variables inside the parentheses. Okay, so let us simplify. So we have here 2 raised to 1 times 2. So for 2, then we have here for m. So m raised to 3 times 2. Then we have n raised to 5 times 2. Over, we have here x raised to 2 times 2. Then y raised to 3 times 2. Then multiply it to the simplified form of the second factor. So we have here x raised to 2 times 3. Then we have here y raised to 1 times 3. Then z raised to 3 times 3. Over, we have here 3 raised to 1 times 3. Then we have here m raised to 1 times 3. Then n raised to 2 times 3. 2 times 3. Then let us simplify. So we have here 2 raised to 2. Then m raised to 3 times 2. So m raised to 6. Then n raised to 5 times 2. So we have n raised to 10. Over, we have here x raised to 2 times 2, which is 4. Then y raised to 3 times 2, which is 6. Then multiplied by this one. So we have here x raised to 2 times 3, 6. Y raised to 1 times 3, which is 3. And then we have here z raised to 3 times 3, which is 9. Over 3 raised to 1 times 3 is 3 raised to 3. Then m raised to 1 times 3, which is 3. And n raised to 2 times 3, which is n raised to 6. Okay? And then let us simplify this. So we have here what is 2 raised to 2. So we have 4. M raised to 6. N raised to 10. Over x raised to 4. Y raised to 6. Times, we have here x raised to 6. Y raised to 3. Z raised to 9. Over, what is 3 cubed? So it means 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. Then, we have here m cubed n raised to 6. Now, we can use the quotient law for this particular example. Okay, let us simplify this. So, we will use the power quotient law of exponent here. So, if we have 1 in the numerator and 1 in the denominator with the same base, so we can subtract their corresponding exponent because we don't have an exponent outside the parentheses. So this is for the quotient law of exponent. So we cannot simplify the numerical coefficient because 4 over 27 is already in its lowest term. Okay? So we have here 4 over 27. Now for the variable, so we will write the variable in the numerator if and only if the exponent of the variable in the numerator is greater than the exponent in the denominator. Then we will write it in the denominator if and only if the same base and this base has a greater exponent written in the denominator. Or in other words, pag magsusubtract tayo ng exponent na may parehas na variable. And saan natin siya ilalagay or isusulat? Isusulat natin siya sa numerator kung mas malaki yung exponent ng variable sa numerator. isusulat naman natin siya sa denominator kung mas malaki yung exponent ng variable na nakasulat sa denominator. Okay? So, let us have m. So, since m has a greater exponent than in the denominator, so we will write it in the numerator. Then we will subtract. So, we have here 6 minus 3. Then we have here the variable n. So, the variable n has a greater exponent in the numerator. So, again, we will write it in the numerator. Then subtract. So, 10 minus 6. Then we have y. So, again, y is in the numerator and the other y is in the denominator. But this time, we have the greater exponent of y written in the denominator. So, we will write y in the denominator, then subtract 6 minus 3. Then for z, we have here for x. So, x raised to 6 over x raised to 4. So, we have here x written in the numerator with the greater exponent than the denominator. So, we will write it in the numerator. And then we have here 6 minus 4. Then for z, so we don't have z in the denominator, so we will just write it in the numerator. Then z raised to 9. Then let us simplify. So we have here 4 m raised to 6 minus 3. So we have here 3. Then we have here n raised to 10 minus 6. So we have 4. Then we have here x raised to 6 minus 4. So we have 2. Then we just write z raised to 9 over 27 y raised to 6 minus 3, which is 3. So therefore, the simplified form of the given example in number 5 is 4m raised to 3 n raised to 4 x squared z raised to 9 over 27 y cubed. Okay, that's all for today. So if you have question regarding this lesson, you may write your question in our comment section, and then we will find or we will make a way to answer your question. Thank you for watching.